We are Team 25 and we are going to talk about thermocouple sensors. I'm 2000 ECE 030 from Vigo and
And I am 2016 ECE 34 Phue Pwint Thura. Then, okay. What is thermocouple sensor? A thermocouple sensor is used to measure temperature and is made with two wires with different metals, which are joined at one end to form a junction. This sensor has two dissimilar conductors and two junctions and measure the temperature of the environment by measuring the change in voltage according to change in resistance, which is caused by deforming of two conductors. Thermocouple sensors are desirable because of low cost, simple to use, and providing accurate readings. How it works. When two wires composed of dissimilar metals are joined at both ends and one of the ends is heated. This is a continuous current which flows in the thermoelectric circuit. If this circuit is broken at the center, the net open circuit voltage the CPAP voltage is a function of the junction temperature and the composition of the two metals, which means that when the when the junction of the two metals is heated or cooled, voltage is produced that can be related back to the temperature. Type of thermocouple sensor. There are two main types of thermocouple sensor. They are base metal thermocouples, JKDE and N types. Novel metal thermocouples, RSC and GB types. Base metal thermocouples. Type J. The type J has smaller temperature range and the shorter lifespan when it is in high temperatures than type K. It has equivalent in expense and reliability like Type K. Type K. The Type K is the most common type of thermocouple. It's inexpensive, accurate, reliable, and has a wide temperature range. The Type K is commonly found in nuclear applications because of its relative radiation hardness. Maximum continuous temperature is around 1100 degrees Celsius. Type D. The Type D is very stable thermocouple and is often used in extremely low temperature applications such as ultra-low freezer. It is found in other laboratory experiment uh, environment. Environment. Type D has excellent repeatability between minus 380 Fahrenheit to 392 Fahrenheit. Type E. The Type E has a stronger signal and higher accuracy than the Type K or the Type J at moderate temperature ranges of 1000 Fahrenheit and lower. The Type E is also more stable than the Type K, which adds to its accuracy. Type N. The Type N shares the same accuracy and temperature limits as the Type K. The Type N is slightly more expensive. The Type N has better repeatability between 572 Fahrenheit to 932 Fahrenheit, 300 degrees Celsius to 500 degrees Celsius compared to the Type K. Non-metal thermocouples. Noble metal thermocouples. Type R. The Type R is used in very high temperature application. It has a higher percentage of ruthenium than the Type S, which makes it more expensive. The Type R is very similar to the Type S in terms of performance. It is sometimes used in lower temperature applications because of its high accuracy and stability. Type R has a slightly higher output and improved stability over the Type S. Type S. The Type S is used in very high temperature applications. It is commonly found in the biotech and pharmaceutical industry. It is sometimes used in lower temperature applications because of its high accuracy and stability. The Type S is often used with ceramic protection tube. Type C. It is is suited for measurements in the 0 degrees Celsius to 2320 degrees Celsius or 32 degree Fahrenheit to 4208 degree Fahrenheit range. This thermocouple is well suited for vacuum furnaces at extremely high temperatures. It must never be used in the presence of oxygen at temperature above 260 degrees Celsius or 500 degree Fahrenheit.
Common thermocouple temperature ranges. Type G temperature range 0 degree to 750 degrees Celsius. Standard limits or area greater or 2.2 degrees Celsius or 0.75 percentage. Special limits of area greater of 1.1 degrees Celsius or 0.4 percentage. Type K temperature range minus 200 degree to 1250 degrees Celsius. Standard limits of error greater of 2.2 degrees Celsius or 0.75 percentage. Special limits of error greater of 1.1 degrees Celsius or 0.4 percentage. Type E minus 200 degree to 900 degrees Celsius greater of 1.7 degrees Celsius or 0.75 percentage as standard limits or error. Special limits or error greater of 1.0 degrees Celsius or 0.4 percentage. Type T minus 250 degrees temperature range minus 250 degrees Celsius to 350 degrees Celsius. Standard limits or error greater of 1.0 degrees Celsius or 0.75 percentage. Special limits or error greater of 0.5 degrees Celsius or 0.4 percentage. Type S mass operation temperature 1482 degrees Celsius. Mass exposed temperature 1704 degrees Celsius. Recommended environment oxidizing inert. Type R 1400 mass operation temperature 1482 degrees Celsius. Mass exposed temperature 1704 degrees Celsius. Recommended environment oxidizing inert. Type B mass operation temperature 1700 degree and 404 degrees Celsius. Mass export temperature 1770 degrees Celsius. Recommended environment oxidizing inert. Type C mass operation temperature 2760 degrees Celsius. Mass export temperature 3000 degrees Celsius. Recommended environment vacuum high purity and hydrogen and inert. Times or thermocouple sensors. A weather wire thermocouple is the simplest form of thermocouple. It consists of two pieces of thermocouple wire joined together with a word bed. Because the bed of the thermocouple is exposed, there are several application limitations. The weathered wire thermocouple should not be used with liquid that could corrode or oxidize the thermocouple alone. Metal surfaces can also be problematic. Often, metal surfaces, especially pipes, are used to ground electrical system. The indirect connection to an electrical system could impact the thermocouple measurement. In general, weather wire thermocouples are a good choice for the measurement of gas temperature. Since they can be made very small, they also provide very fast response time. And thermocouple broke consists of thermocouple wire housed inside a metallic tube. The wall of the tube is referred to as the sheet of the probe. Common sheet materials include stainless steel and inconel supports higher temperature ranges than stainless steel. However, stainless steel is often preferred because of its probe chemical compatibility. For very high temperature, other exotic sheet materials are also available. Few or a line of high temperature exotic thermocouple probes. Surface probe. Measuring the temperature of a solid surface is difficult for most types of the temperature sensors in order to assure an accurate measurement. The entire measurement area of the sensor must be in contact with the surface. This is difficult when working with a rigid sensor and a rigid surface. Since thermocouples are made of pliable metals, the junction can be formed flat and thin to provide maximum contact with a rigid solid surface. These thermocouples are an excellent choice for surface measurement. The thermocouple can even be built in a mechanism which rotates making it suitable for measuring the temperature of a moving surface. Wireless thermocouple, Bluetooth wireless transmitter that connect with smartphone or tablet to log and monitor temperature measurements. These transmitters measure different sensor inputs, including but not limited to temperature, pH, RTD, related humidity. The data transmission is performed Bluetooth wireless technology to a smartphone or tablet with the app installed. The app will allow the smartphone to create and set up multiple transmitters. Learning outcomes. We learned what is the thermocouple sensor, how the browser is working in it, types and styles of thermocouples. We got a lot of sensor knowledge by learning this. Thank you.